So let's start writing our first program using logic operations. How the program should work. You can see in my comments in the network first that I have some information about realization our program. Our button first, so for example button which is connected to our input in the PLC, should switch devices. Device number 1, 4 and 5. So for example, it is button from our light in one room, and for example it should switch on device 1, for example lamp 1, lamp 4 and lamp 5. Second button switch another devices, one also first device, second and seventh. Button 3 should switch off devices, and it is device first, 5 and 8. Button 4 should change state of devices, and it is device 1, 3, 4, 6 and 8. Button 5 change state rest of devices not used in previous button 4, so here it is second, 5 and 7th. And the last button 6 should change state of all devices. We know about 4 word logic operations blocks, so we should use them in order to write such a program. For example, it can be a program even in controlling intelligent house in our flat. So how we should make it? We should make it in this way that first of all we should write some tags in our PLC tags. Here we have our outputs, so you can create the same PLC tags as I have. So from device 1 to 8, so it is exactly the whole 0 byte of outputs of the PLC. So from Q0.0 to Q0.7, and also buttons from 1st to 6th. But I use not input from the PLC. If you have some simulation, some simulator of inputs connected to your PLC, you can change these memory bytes to inputs. But in order to show you how it works by our simulation in the program, I change it for the memory. When you have got this everything, we can start writing our program. So first of all, we would like to write program for our first button. How we should make it? If you remember, we can switch on device, selected devices, for example device first, fourth and 5, by using one of the fourth function, and it should be function OR. Here, as you remember, we should write our whole byte. On output, we should put the same byte because we would like control only this byte. And here we should put our mask. The mask should be constant because we will not change it. And now it is very important to show you one more thing, because we want to control our devices first, 4 and 5. You should know that the bits are numerated from the right to the left, because it is caused by the binary system. So if we would like to control it from the right to the left, so first device is on first position, so I should write everything from right side, yes. Second device should not be controlled, so we put 0. Third device also not control. Fourth control. 5 control. 6 not control. 7 not control, and 8 not controlled. So it should be something like this, what I wrote here. Of course, if you want make some complicated readings in our program, you can also use calculator, change to programmist view, for example for Word, because the last one in byte will be a sign, so we would won't have something such a problem with sign. We choose Word and select exactly devices which we want to control. Normally it is 2 to the power to 0 on the first position, but we here put our first device, so it is our whole 8 devices. We would like to control first device, fourth and 5. So it can be also the value of 25, and I prefer something like this. Sometimes it's worth to read once again which devices we control, but we can also, instead of this number, write 25 in decimal system. In decimal system we do not have to write here that it is in decimal system. Only when we write in binary system we should write this 2 hash and 8 digits. Something like this we have got, and now we would like start this operation by some condition. This condition is our button 1. So when we switch our button 1, it should be realized. For example, we can write it exactly for the rising edge, because when we stay it will work permanently and other operation cannot be realized. So when we have got this, we have to write here some memory byte in order to save our previous operation. For example, M50.0, because I know that this tag is free, and I can also rename this tag, for example, slope first. Change it. So our first program is prepared. Next program I make in the same network, because here we have got exactly the command of working our network, so we can use it. We copy exactly these things. So first thing we change to our second button, so we choose button second. We should change our memory for slope, because it must be only one in usage, so we cannot use the same in the second slope, and also rename slope second. Now we should only change which devices should be controlled. How we make it? We can use our calculator once again, and what we should make it now. We want to control device first, second and 7th. So it is 67 in decimal system, so instead of 25 it is 67. So we have now realized second button program. For the third button we can also the same thing, copy and paste. We wrote here button third like in previous. Here once again new slope, once again rename, and now we have to change our function, because now we want to switch off selected devices. We realize it by the AND logical function, so we change OR to AND. We also make this operation on byte, but we have to change our mask. Now you see that we can switch off selected devices by AND function only by using zeros in this function. So by using calculator once again, here we should select these devices which we want to switch off. We switch off devices using the 0 number. So we want to switch off first device, so I remain here 0. Second device should be stay in the same state. Third device also without changing state. Fourth device also. 5th device should be switched off. 6th without changing, and 7th also without changing. So we only switch off devices 1st, 5th, and 8th. So our coded binary system into decimal system, it is 110. So writing here 110. Next thing, the same, we should make it exactly for next button 4th, slope 4, but I haven't got it prepared now, so I should write 50.3 and now rename. And now when we have it made, we have to read our comment, so we should change state of devices. For changing state of devices, we use exclusive OR function, and we put the 1 on places of devices which should change state. So in our case, it is 1st device, 3rd device, 4th device, 6th device, and 8th. So it is 173. 173. Of course, if you want, you can write here in a binary system. It's no problem. But I prefer writing in some coded function. Next, button 5. M50.4. Rename slope 5. And come back to our comment. We should change state of device 2nd, 5th, and 7th. So 2nd, 5th, and 7th. So it is 82. 82. And our last function. Now I copy only this part of the previous program. It is button 6 now. We use M50.5 our memory tag and write here slope 6. Now we use invert operation because we want to change state of all devices, and we only say what is of input of our inversion and where we should write our result. So we want result write once again on this variable from which we take our bytes. So this is everything. If you want now see how it works, so the best way is to create watch and force table in order to control how it works, or just load it to our PLC. If you have some simulation of inputs, you can now switch on first input and see how it works. In my case, we have got here only memory bytes, so we can only changing it by changing here the state. We can make it exactly from the program. As we see, I had remembered that our M00 is modified to 1, so something was changed. Here is our values coded in hexadecimal system. If we want check which it is exactly value, the best way is to add new watch table and there watch our byte of QB0. We want to control it in binary system. We start our monitor. We can change this window to the float, so we can take this window smaller and control exactly like in this way, that we have got here our value. We have some value as we see, so we can, for example, now check if our devices are correctly switching.